Tonight you're going to learn about linear relationships, what they are, and why we use them. So some vocabulary, and you need to make sure with this vocabulary that you're writing the definition down, as I did not give you the definition in the graphic organizer. So a variable is a representation of unknown quantities, and we usually represent it with a letter. The independent variable is a variable that's influenced by nothing, and we usually represent it with the letter x. The dependent variable is a variable that's influenced by the independent variable, and we represent it with the letter y. The rate of change is a proportion, a fraction, that describes how the dependent variable changes as the independent variable changes. And constant just means no change. So what is a linear relationship? A linear relationship is just a special relationship in math where the independent variable and the dependent variable has a constant rate of change. And the rate of change is constant because the changing in the independent variable is constant and the changing in the dependent variable is constant. For example, if we look at distance in miles and time in hours, it is a linear relationship. As the hours on the road increase by 1 hour, your distance will increase by 65 miles, and your rate of change is your speed, which is 65 miles per hour. And that's assuming you're going 65 miles per hour the whole entire time. Why do we like linear relationships? So math in general is used in a variety of professions to describe and model relationships between variables. We want to describe the world. And we like linear relationships because they're the least complicated to work with. We can easily plot them on a graph and predict future values. And once we identify a true linear relationship, which is rare, or an approximate linear relationship, we construct a linear function to help us understand the relationship. So how do we identify the linear relationship? We identify a linear relationship using the following characteristics. There's a constant change in x, which is the independent variable. There's a constant change in y, which is the dependent variable. The rate of change, which is the change in y over the change in x, is constant, which means it does not change. The graph of the data is linear or approximately linear, which means it makes a line. And the equation of the graph is some form of y equals mx plus b. So here's example 1, which I do want you to write down because it is an example of a linear relationship. So example 1, the question is the following a linear relationship? And if so, describe the rate of change. So the first question says, is the change in x, the weight of the bananas, constant? And it is because we change by 1 pound each time. So the weight of the banana changes by 1 pound. Is the change in y, or the price, constant? Yes, because it changes by 89 cents each time, not 39 cents each time. Is the relationship between the weight of bananas and the price linear? Yes, because the change in weight and the change in price are both constant. And so the rate of change is as the weight of the bananas increase by 1 pound, the price increases by 89 cents. So I do want you to write just this example down. The next example, which is example 2, is just another one to make sure we have it. So example 2 says the following linear relationship. If so, describe the rate of change. You do not have to write this one down. So is the change in x constant? Yes, the x values increase by 1 each time. Is the change in y constant? No. Y increases by 3 from 1 to 4, 5 from 4 to 9, 7 from 9 to 16. And because the change in y is not constant, the relationship is not linear. It is actually what we call quadratic because we're squaring the x. That's for a later thing to learn about. And that is the end of the video, and I will see you guys tomorrow in class. Make sure you have your notes and everything is written down because you will have a warm-up quiz tomorrow.